Alright, time for another DraftPhysics.com video presentation. So we'll start with a lesson, a physics lesson. Fun. So I was thinking about ways of proving, that this idea that you get twice the energy when something reflects off a surface, the free momentum experiment, we'll illustrate it again, but Anyway, ways of illustrating how it just can't be true. You just can't get more energy from an explosion than the explosion has. And so let's say you did have an explosion in a little gun, and you converted the explosion into air pressure. So all we have here is air pressure, and you can put two corks in, There's a cork in here and a cork in here. And you can sort of understand that if I let one of the corks is loose and it can fly out and the other cork can't, that it's going to shoot the cork much faster. So if both corks are even and they both shoot out, I'll get half the velocity that I'll get if I don't allow this side to release any energy, because the energy basically will reflect off of this surface and add to this thing's energy. Now the concept is, when can energy reflect and when can't it, and do photons reflect? And so yes, you can get into a lot of complex physics. But I would argue that the basic concept is this yielding argument, and if something doesn't yield, if you can keep it from yielding, keeping from recoiling, that in fact more energy has to go the other way. And you have to conserve the momentum. You can't make directional momentum. There's no real such thing. They don't really cancel each other. So you start with an explosion, for all energy, let's say, an expansion of some kind. And there's a component going this way, and there's a component going this way. And there's obviously components going in all kinds of directions, but we're only concerned with conservation. So we only need to take one of those vectors and play with it. And so then you have this, You have something with, say, 100 momentum. Yeah, now this is in the universe, but it's heading for Pluto or something. This is the only part you're going to get, from the explosion. And, the theory would be is if this interacts with something, I'm arguing it can only do two things. It can either reflect the energy, or it has to absorb the energy, but it can't reflect it and absorb it. So that's the simple argument I'm making. And as I've tried to illustrate, their theory does this weird thing of, if I bang two equal mass objects into each other, I get a complete transfer of exactly what I started with. But if I start to add a little tiny bit of extra weight to the one object, all of a sudden I start creating more momentum this way. The momentum I transferred is now 101, and then it goes to 102, and then 103, and 104. And because I'm getting a reflection, they're saying that those two things cancel out, that they're not real momentum in the universe. It doesn't make much logical sense, I'm afraid, in the context of what the science proves, which is, if I let it go both ways, I get less velocities. I don't get more velocity anywhere. I don't retain a velocity. I don't get more than what I started with. And that's all there you get. So the idea is we're only trapping half the explosion when you're using a projectile of some kind. All right, and again, so their theory is that if I bang this against a bigger object, what I'm going to do is I'm going to create, say it has 100 momentum, I'm going to create something that has 100 plus, and I'm going to create a reflection of some plus number. And the pluses are supposed to cancel out all the way up to 2. So this really doesn't have anything to do with kinetic energy, because it doesn't have anything to do with the squared function. This just says that somehow I can double the amount of energy an explosion has, or an event has, by causing a reflection. And I'm arguing that no, as soon as this side yields at all, this side can't get a reflection. And that's what's happening in the Newton's cradle, right? I mean, you're banging two even objects into each other, and you're transferring the energy directly. There's no reflection because you perfectly yielded. The energy went that way. And if you're not yielding, then it has to go back this way. And the more you don't yield, that is, once you get to some object that won't move, won't absorb velocity, then all the velocity has to go this way and you get 100 back. And that's a perfect elastic interaction. You throw it at the wall, it bounces back with 100% of its energy, then you didn't do anything that way. You couldn't have. And you certainly didn't do twice as much energy that way. So again, I have illustrated in a previous video, I'll do it real quickly here, that if this thing was true, that you could double the amount of energy, or that you could, based on filtering, change how something's moving. I could just put a box in space and make one side sticky, that is, nothing reflects, and the other side completely reflective, which I don't know exactly how to draw either. But anyway, so one side is sticky, one side is reflective. Now I just let the universe do its thing, and everything that sticks here, okay, this would be adding, say, 100 momentums, okay, and the thing that comes in this way somehow would be hitting this wall with 200. Somehow the wall will go this way with 200, okay, but it only came in with 100. So there would be a huge differential, and it would just keep adding the differential every single time something hit from this side. It would give it a real velocity, so it would just keep gaining and gaining and gaining velocity because of this differential. Hundreds on both sides, the same pressure on both sides somehow is converted into twice the pressure on this wall going this way. Just can't work. This side only gets 100, this side gets 200, just sitting in space. And again, this happens constantly, so as every single thing hits it, it starts gaining more and more and more and more and more velocity. It would go infinitely more velocity. Eventually, if you gave it enough time, it would just keep collecting every bit of energy in the universe. So anyway, well, collecting. Obviously, it didn't collect it. That's the whole point. Is you can say it has twice the momentum, but if it's not moving, it doesn't have any momentum. Not complicated logic. All right. So as much as I like I said, you can draw a diagram where you can make this make sense. It's an internal event, but it won't make sense in terms of if you actually try to build it. It won't work. All right, so we'll do comments. Shit. It's just, yeah. Anyway, this was one of the more brilliant piles of crap. Optical mouse 2. I love people that they can't come up with an original name, so they take some other name and put a 2 on it. Painful. Anyway, cuckoo physics. So what is that? I mean, it's just so lame. It's so limp. Come back when you can fuck me with a real dick. I mean, what is that? Not even close. Sorry. I think we'll just block this asshole. Okay. I mean, what the fuck? People are just such pieces of shit. Anyway. Alright. I mean, why does it do this? Whatever this is. Alright, anyway. Okay, so there's this GPOAP. So all these, I mean, it's just unfortunate that, why can't you people find an advocate, okay, and then you can comment to the advocate and he can make a video and, argue your position for you instead of all these word problems you want to create. Alright, please correct me if I'm wrong. Well, what's the odds of you people anybody else being right? Yeah, pretty thin. Momentum P equals mv. Yes, not complicated. Mass. Yes, it's not inertia. It's just mass. It's a number of elemental bits of matter. Okay, velocity, the motion of those bits. Okay, speed in a specified direction. You can't have speed in anything else but a specified direction. Nothing in the universe is moving in an unspecified direction. I don't know why you think it's a possibility. It's just too silly from my perspective that you think there's a possibility that you have speed in an unspecified direction. Oh, fuck. Force, F equals ma, width. So again, the force is really mv. The force is your momentum, as Newton stated. You want to go twice as fast, you want to have twice the momentum, apply twice the force. Force is momentum. It isn't ma, whatever that is. Okay. A change in velocity within a specified period. There's no specifying a period. It doesn't matter. The change of velocity is an event. If you do it fast, you do it slow, it doesn't change the acceleration. The acceleration is exactly the same whether you do it really fast or you do it really slow. How can changing the amount of time the acceleration takes change the fact that you accelerated? You change the acceleration. So it really is irrelevant. And in this case, it's even dangerous just because it actually is 9.8 meters per 1 second. It's not 9.8 meters per an unspecified number of seconds. Force is also said to also be change in momentum within change in time. So again, it's changing time doesn't mean anything. There's absolutely no reason to say change in time. So it just doesn't matter. All that matters is the change in the momentum. That's all there is. Now, if you want an answer as a rate, if you want to know what the rate of change is over a period of time, over a month or something, and you want to find the average rate of change, well, then go ahead and multiply by time. But if you're not interested in the rate, you just want to know what's the force, then time is irrelevant. You just say, what's the momentum? How much did the momentum change? Well, if the momentum changed by 30 miles an hour, now you know how much force was applied. Okay, it seems to me that you need some motion to have an acceleration. It seems to me that accelerations are always just changes in velocity. They're made out of velocity. You're changing the size of the elephant. You change the size of the elephant by adding elephant or subtracting elephant. There's nothing else you can add or subtract. The change is just taking away some elephant or adding some elephant. So it's force really not defined with A equals 0. Frankly, I can't make any sense out of that, so it doesn't mean anything to me again. I mean, Newton's equation sort of speaks for itself in the sense clearly Newton was talking about a rate. And if you don't need a rate and you just want to know the net force, you just say, what's the net change in the momentum? The net change in the momentum was the net force. When I push something against the wall so that it doesn't move, all aka net forces involved, friction and gravity, etc., are said to be 0. Well, again, this is baby talk. Okay, I'm not doing 0 work when I'm holding a weight up. I'm sorry. I'm tired of this nonsense of saying an explosion has 0 momentum. If physics wants to say things that stupid, then go ahead and say things that stupid. I started with nothing moving. I exploded something, and things are moving preposterous speeds. But there's no momentum. Because that canceled out that. Okay. But should I really describe this action as force or pressure? So all these words are messed up. I'm saying that weight, okay, energy, heat, everything is all the same thing. There is no distinction between these things. They're all the same thing. Heat is energy. Everything is energy. that's moving. So in a sense, you could just say velocity is energy because, well, if it doesn't have a mass, it can't move. It can't be a something then. So all the somethings, they give them a velocity and they now have energy. Okay. Should I use F equals ma? No, I'm saying it's F equals mv. F equals momentum. Momentum moves everything in the universe. Nothing moves without exchanging momentum. Period. You have to exchange the momentum. The force does have momentum. Gravity is momentum inducing, so therefore it is a momentum force. All matter has to be obedient to gravity. There's no anti-gravity matter. Clearly, gravity is a manifestation of some energetic force, okay, being applied to the matter. A force with momentum. Our P equals change in the force per fixed area. I don't know if we want to get into areas, but where change in force equals PA does not equal F. I don't know what you're talking about now. But anyway, change in force between two instances of time, aka over a time period. So again, it doesn't matter. Now, it doesn't matter in any long-term way. Like, again, if you were taking an infinite amount of time to acquire the acceleration, then you could argue that the average acceleration is almost an uncalculable, meaningless number. Because the time period is so long. Could be non-zero when the force could be zero on average during that period. So again, if you're going to break the acceleration into pieces, then they're separate accelerations. So if you're taking a very long time, you'd have to argue that you're almost taking different units of acceleration. You'd have to examine each unit at each particular moment. Is weight really change in force? Well, that's how you acquire it. Weight is just your velocity and your mass. Weight is just your momentum. So again, to have weight, you have to have energy. Weight is moving matter. Okay, or something like that. Scales measure energy. This is an energy detector, and it measures, an energy measurer, essentially. It moves because the energy of the gravity shows you that it exists, because it moves the spring. The mass is given velocity. So disregarding dividing by time periods, maybe. Is weight really change in force or something like that? Yeah, weight is showing you that the thing has now collected force. If it has weight, it has collected force from somewhere. So degrading dividing by time periods, maybe. So disregarding dividing by time periods, maybe. Yes. Force equals momentum. Okay. Weight equals momentum. All right. Weight equals change in a force, pressure, area. No. The pressure is the force, you could argue, right? And we're talking about how long you apply the pressure. Is the velocity. The time is the velocity. You could argue the components are just, it's just mv. You've got to consider both things, the mass and how much mass there is and how fast is it moving. All right, W, I imagine that's weight, equals F equals PA. Oh, there you go. Now you got it. You don't need the change in. But anyway, well, obviously, I guess if you're trying to measure the change in the weight, but really don't need to do the changing things. Force equals change of momentum. Force equals the momentum change. Yes. If you're applying, if something's momentum changed, and there was a force that did it, so you just figure out, well, yeah, there was a force applied. A momentum was applied to change my momentum. Momentum changes momentum. something else's momentum changes your momentum. All right, force equals momentum. There you go. Momentum equals change in what? Momentum equals change in. Momentum equals mass and velocity. Moments? Yeah, fuck at that. Screw that terminology. Not useful at all. So I don't know what that is. Change in J. I don't know. So we put some new thing in there. So what is a moment? Who cares? I don't. It's kind of. It's kind of gay. Anyway, I disregarded time, but I think it's logical to define moment equals momentum times time period. So it really doesn't. I would argue. Again, it doesn't. The change is going to be dictated. The speed of the change is dictated by the velocity that's already in the momentum. If the velocity is really slow, then the change will be slow. If the velocity is very high, then the change will be very fast. Okay, now I can reintroduce time into the equations for whatever reason I don't know. So F equals change in momentum over change in time. Well, again, we already pointed out that change in time is irrelevant. It doesn't matter. And that doesn't tell you the force, that'll tell you the rate. So if you divide by time, you're going to get a rate number because the time will be in seconds or hours or months. And so then you're just going to get a 9.8 per unit of some number of seconds. So if that's what you want the force in, I want the force in joules. So I want the net force. So if I'm looking for the net force, I don't need to do this time thing. And P equals, I don't know what the J is, divided by time, are fairly easy to understand, but what should I do with W? So is this weight again? Again, work is just a portion of something's total energy. Okay, is weight really proportional or inversely proportional to time? So again, you can't separate velocity from time. So velocity is already in units of time. So you already have time in the equation. So it just matters on how fast it happens. If something's moving fast, then everything that's going to happen is going to happen fast. I mean, it's just, the speed is going to be decided. The speed of the interaction, which I don't think is terribly relevant anyway, is going to be dictated by the velocity. And the velocity is already built into the momentum, so why worry about it? Who cares how long a period of time it took to accelerate? That's the whole point of the argument, really. I mean, look, it's 9.8 meters per 1 second. It doesn't matter whether I'm an asteroid going 6 million miles an hour. Let's say an asteroid comes at us at 6 million miles an hour. It's only going to gain 9.8 meters per second. That means it's going to travel a gigantic distance in gravity. And it's not even going to get that 9.8 meters because it went through the gravity so fast that it didn't even get to a second. It couldn't even absorb 9.8 meters per second. It couldn't even absorb 1 unit of 9.8 meters per second. It couldn't even gain that minuscule amount of extra energy. It gains absolutely nothing from the Earth's gravity. If it's moving at very, very fast speed, it gains nothing. It's meaningless. So distance or time doesn't matter. You're just saying how much did it change the velocity, the momentum of the asteroid? Well, it changed it almost nothing at all. It was meaningless as a contributor to its velocity because it was such a tiny amount of time it was in any relevant gravity. All right. So that was 5 days ago. So he has updated his statement. Let's see. If I'm hanging a weight under a spring instead of pressure stress on a spring, I don't know, so I guess he means compressing one, it'd be considering tensile stress within the spring. I don't know. So W would be proportional to K delta X. So the spring constant times the change in the distance. But again, that's just Hooke's law. The distance really isn't the subject. The subject is how much momentum is it. The spring is measuring the momentum. It's collecting it. It's taking it away from the object and storing it in the stress in the spring. The momentum goes from the object into the spring. Like a Newton's cradle. Yeah. And now the spring has it, but the spring, unless you create some mechanism for it to keep it, the spring will reject it. Alright, so then he says, you may be right. They might be falsely attributing one of Euler's law to Newton. So again, I don't know why you can't just say, no, they're attributing science. They're assuming that Leibniz was doing good science when he did it, the stupid, it looks like a duck, when he pointed at the platypus. And they're saying that's good science. And the argument is no, if Leibniz took a little bit of time to think through, he would have figured out that, oh, wait a minute, how much energy you can acquire from gravity is completely dependent on how much time you're in this gravitational stream. It's a stream. If you only poke your finger in it, you're not going to get much energy out of it, if you go poking right through it. Okay, although their laws of motion seem to be closely related. I don't know if I want to bother with this, clearly Leibniz proposed his mv squared about a year before Newton published the Principia. That has all the details in it. So I'm just saying, it seems like everybody could have made a mistake. Galileo was so close, to pointing out it's a time-dependent force and figuring out that it has a constant and that there's an inverse square law. All of that was not very far from his reach. And it's kind of amazing that it did take as long as it did, this 50 or 70 years for Galileo's observations to, Galileo, Newton was born when Galileo died, right? Anyway. Euler's first axiom, or law of balance of linear momentum or balance of forces, so these are just conservation laws essentially, states that in an inertial frame, the time rate of change of linear momentum p, I really don't want to do this, of an arbitrary position, there's no arbitrary positions, of a continuous body is equal to the total applied force. Yeah, so he's just saying, again, momentum equals force. Okay, acting on the portion that and is expressed as F equals dp over, again, a change in time, which doesn't mean anything. He also said that if force is the sum of the integral WRT mass density volume of the body, like I said, I don't find this at all useful. We know the silly arguments that defended mv squared, and I'm saying they're silly. Okay, I've pointed out how they're silly. 4 times the distance, okay, does not mean you did 4 times the work when you roll a ball. And the same is true in gravity. The fact that you have to drop something from 4 times the distance to double its velocity is just a reflection that to be in the gravity twice as long, you need to go 4 times the distance, or you won't be in the gravity long enough to double your velocity, because you're not going to collect the force. Your motion is against your collection. You can't collect it if you're moving through it. So since your motion is tied to how much time you'll be in it, clearly that's all that matters. You have to collect the 2 units of gravity. You have to be in the gravity the 2 units of time, because you're going to collect the gravity in 9.8 meters per 1 second. Come on. And that mistake you know, this stupid, it looks like 4 times the distance, therefore it must be 4 times the energy. It's just wrong. And then you're talking about the resurrection of the nonsense, right? After the Newtonians defeated it, it was resurrected, you know, 50 years later, with a silly clay experiment, you know, where people didn't realize that the shape of the object you're dropping into the clay changes how deep the clay will penetrate. This is also brain dead. This is also brain dead. Oh, wait, this is the one. We didn't do this one yet. Alright, change in time only applies to a graph, fuck you, of mathematical function versus time. I'm just saying, there's, as soon as you multiply a velocity times a time or something like that, or a distance times a velocity, these are things that have the same component in them. You're just multiplying a cause times its own effect. There's no point. Okay, in order to get a slope, aka time derivative of the graph, well, whatever, all that is useless if you're multiplying two things you have no business multiplying. And especially if you're multiplying causes times effects, in my opinion, you're making kind of an obvious mistake. For physics and mechanics, it's meaningless to say change in time unless you are adjusting a clock. Well, it's clearly meaningless, you know, to say time is changeable. So right there you're in trouble. And all you're really saying is it's a quantity of time. So what's the point of saying change in time? You're just saying how long did it take? He should just call it time interval. There you go. Or something like that. Duh, exactly. Experimentally, all time intervals are normally considered to be the same, and only a change in function, physical function, position, speed, etc. is considered. Well, I don't know how time intervals could all be the same, but whatever. The point is the interval of time in this case is completely fixed to the constant, and so if you change the time, you're changing the amount of force. It's not 9 meters per any amount of time. It's 9.8 meters per 1 second. If it's a half second, then it's 4.9. If it's a, you know, I mean, this is, you know, come on. Anyway. This is so brain dead. So another anonymous coward who can't do anything like a grown-up. He has to do it like a little sissy and hide. If kinetic energy is a linear function of velocity, so if kinetic energy, if gremlins eat bananas, okay, that's all you're saying to me, frankly. If gremlins eat bananas, then it is also a squared root function. Yes, if you've squared something, then obviously there's a square root function somewhere in the universe because of conservation laws. Duh, but who cares? It's, you know, you're just talking about what kind of clothes gremlins wear. Who cares? Then it's also a square root function of the height of an object falls from. And again, the argument is it's obviously not. It's 9.8 meters per 1 second. That's all you get. 9.8 meters of change in your velocity. That's it. In 1 second. And then you have to wait a whole nother second to get 9.8 more. You get 2 units of acceleration. That's all you get. 2. There's no 4 units of acceleration. There's only 2 units of acceleration. So why the hell would I pay any attention to this nonsense you're talking? And this breaks conservation of energy. You don't believe in conservation of energy. Overtly, you're saying, depending on how heavy an object I throw something at, I can create twice as much energy. So, I mean, what sense are you making? I have a rubber ball. I throw it at a wall. If it sticks to the wall, I only have 100 joules of energy. Let's say it was moving with 100 joules. I have 100 joules of impact. I throw a rubber ball that bounces, and all of a sudden I have 200 joules going that way. Well, you know, come on. I really don't think you're dumb. I think you are enough to not understand that. I think you're really dumb. You're petty. You're resentful. You got all kinds of ego problems. That's why you type crap like this, is to make yourself feel like you're winning somewhere when you're just talking shit. Especially since it's been explained to you in video and comments before. What has been explained? That 2 units of force are 4 units of energy. That's what you've explained. 2 units of force, 2 units of gravity, 4 units of energy. That's your logic. 1 plus 1 equals 4. You've explained why that is. Oh no, that's right. That's the part that's missing. Why 1 plus 1 equals 4. You've just stated it as a law. The law of our stupidity. Sorry. 1 plus 1. 1 unit of force plus 1 unit of force equals 2 units of force. Do you really think anybody is fooled? Do I think any of you are not fools, is the real question. Do I think humans have any integrity? Well, clearly you're proving you don't. So that's all I can only do my half of this. Okay, do I think your completely meaningless, mushy, gobbledygook comment has any structure or any reason for me to doubt anything I've drawn on the board? 1 unit of 9.8 plus another unit of 9.8 equals the exact velocity. So, again, I can just recite it again, but it's 2 times the force. There's only 2 units of gravity collected. It's in 2 units of time, which makes perfectly good sense. It's 2 units of velocity, and it's 2 units of weight. Why should I think there's 4 times anything? Why should I think there's any 4 that's relevant? By your incoherent babbling. Let's see. What do you think the average IQ is of the people who are buying this? Well, I'm just saying, I've often, you want to go ahead and have that challenge. My collective subscriber IQ, I would say, is higher. Okay, much, much higher than any group you want to assemble, frankly. But anyway, and especially the trolls I'm arguing with. Yeah. So anyway, but whatever. Obviously there's a whole bunch of smart people that believe nonsense. Einstein talking about, spooky action when his whole theory is spooky action. There's such an obvious duplicity in that complaint. He complains about quantum action, quantum mechanics, because it's full of spooky actions. And then he proposes a theory that just says gravity is a spooky action. Somehow the space is magically bent and it's applying a magical force, and it's just all woo. Alright, take a little break and then we'll do website comments, which are just the resentful, I've been personally offended because you repeatedly warned me that I was being a troll and I kept doing it, and you finally said fuck you, and I'm resentful. Amazing. Alright, back. So this first comment is a holdover from a previous comment from some asshole, and so sorry, but you really should be able to find somebody that you can make your comments to, and then you could plead with them to please make a video about it or something like that. Because, all of this, these doing these abstract ideas in text without any drawings or any experiments or any illustrations or anything is, in my opinion, kind of stupid, frankly. Alright, so he proposes a thought experiment that doesn't really get to the subject, okay? In my opinion, it doesn't come close, okay? It's a non-functional or useful explanation. So there is this phenomenon. And the basic argument is this really has to do, like every lever, you can have a different kind of fulcrum. You can have a fulcrum in the middle, you can have a fulcrum down here, or you can have a fulcrum actually up here. So you can do it these different ways. And that's really what this is about. It's center of mass, and you're changing these lines, making more weight on one side, less weight on the other. So that's really what's controlling it, probably, is something in that realm. It's the nature of the exact fulcrum. Okay. And so I'm just arguing that, okay, so it does seem a little paradoxical. So I have these two things balanced, and everything's fine. And so then I tip the lever, okay, and now they're unbalanced, okay, but the catch is this one is in more gravity, okay, that's just a fact. It's closer to the Earth, therefore the surface of the Earth, that's the maximum gravity. It's closer to the surface of the Earth. It's an inverse square law going out. So technically this one has more weight, and it's moving this way, and for some reason it stops moving. That's one thing that's a little bit weird. And then on top of that, besides stopping, it decides to go back up. That somehow this side stops here, up here, and somehow up here is now got more energy than down here, which it can't, because this is now heavier. I mean, this weighs 10 plus, this weighs 10. Yeah, you look at it that way. The heavier thing has to keep the movement going. So why would it stop? Why is lifting 10 hard for 10 plus to do? 10 plus should have no problem lifting 10. Anyway, so that's sort of the trick. But it really comes down to the total mass of the fulcrum and, the lever itself. The whole thing has a mass. Okay, and the whole thing, actually, the interesting thing to do would put the whole lever on a scale. And then you could see that the whole lever always weighs the weight of the particles on the lever. It always weighs the mass of the stuff on the lever. It doesn't weigh the mass of the movement. So his answer isn't an answer to this question of, well, why does the heavier mass stop? And then why does the heavier mass actually start going up? That's the question. And again, the answer is not going to be in any MGH kind of formula. It's going to have to be in a center of gravity formula, where what you're really doing is just changing the center of the fulcrum's gravity. You're basically moving the lever on the fulcrum. The center of the lever's mass is moving to a different position, essentially. And so if the center of mass isn't directly over the fulcrum, then the lever isn't going to balance. And so you're basically just shifting the lever's mass one side to the other. So it's the change in the lever's mass on one side or the other that's really allowing for this side to get lighter and this side to get heavier, even though this side is not heavier, strictly speaking. All right. And so I'll read some of this, but I mean, it's just, I don't think this is that interesting, and it's not that relevant to any kinetic energy or to any argument about whether levers conserve momentum. The fundamental argument here is, do springs, do levers, do hydraulic cylinders, do all these things conserve momentum, in the sense that you can't make the spring create different amounts of energy. You can't make a pile of dynamite create a different amount of energy. All you can do is it has to go somewhere. The explosion has a certain amount of heat. It's going to go off as heat. It's going to go off as pieces flying. Something has to move, and only the same amount of stuff is going to move every time it explodes. And we're just talking about the visible stuff versus the invisible stuff. But it can be known that there's only so much. And if we create an experiment where the losses are all going to be the same, and we're going to watch two things move, we can't have less energy. And we can't have more energy. We can't make it give objects more momentum and the same explosion give less momentum. A spring can't give less momentum. It can only give it more or less efficiently. Alright. Posting here because I don't shadow ban anybody, but whatever the fuck that is. I either block you or I don't block you. my YouTube comments. The lever has two masses at equal and opposite positions from the fulcrum. Let's say each mass. So he goes through all this crap, and again, he just starts measuring heights and and I'm saying this isn't going to be the answer. So go ahead, believe whatever you want. I'm really not interested, because what the fuck does it have to do with conservation of momentum? Do levers convert momentums? Can I make a 5-ton train going 10 miles an hour out of a 10-ton train going 5 miles an hour with a lever? And if I can, then we know kinetic energy is absolute shit. Alright, your last video, blah blah blah, you made a response to my comment which subverted my statement and totally bypassed the argument. I don't think it did any of that, and fine, whatever. You believe whatever you wish, okay? I think it's irrelevant, and I think your line of thinking is useless, because it really isn't about gravity. It's about the center of gravity of the lever. But whatever. It's not that interesting a subject. It has a lot of nuance and detail, and you want to argue it. I don't. You drew a scale hanging over a cliff and then said the weights don't care how far the ground is. Yes, I stated overtly that this really isn't about distance in gravity beyond pointing out the obvious. That is, the lower the mass goes, the closer it is to the surface of the Earth, the more gravitational potential it has. The high thing doesn't have more gravitational potential. The low thing does. That's the little paradox I was talking about. This has nothing to do with my argument. Well, it's hard to see because you don't draw anything, you don't show anything, you just talk this crap, and I'm supposed to figure out whether you're measuring the distance from the center of the Earth or whether you're, who wants to go through all that crap? Okay. In my example, both weights, heights, and thusly their gravitational potential energy were referenced with respect to the fulcrum. So again, I don't see the point of this, but whatever. Of the scale, which is at a theoretically known height above the ground or sea level or from the center of the Earth. It doesn't matter. Right, my point is the lower one is in more gravity, therefore it has no reason, okay, to be pushed by something in less gravity. Now the fulcrum is supported by its base, which is not free-falling. So here he's going to say stuff that's just no point. I read part of this and I said, what? He's going to start saying something, just, what's the point? But the weights technically are free-falling. So, no, they're not. So, fuck you. They're only free-falling, technically, when they're moving. So when they're in a static position or they've reached the maximum end of an oscillation, then they're not moving. Certainly when they're reversing direction, they're not moving. So their gravitational potential energy is very relevant. So there is no gravitational potential energy. This is all more baby talk. There's a stream. And the fact is that the stream gets stronger the closer you get to the Earth. The only thing impeding one weight's fall is the other counterweight through the arm of the lever. So that's the only thing we agree on here. So both weights are technically trying to free fall. No, the center of gravity is the fulcrum. That's the key point. The center of mass of the entire lever is at the fulcrum. So both weights are technically trying to free fall. So, they're not technically trying to do anything, and they're certainly not free falling when they're not moving. So you can say that. Now, I'll argue that we're oscillating on top of the Earth, okay? We're constantly pushing into the Earth. The Earth is constantly pushing us back. So to some extent, we have a tiny bit of free fall time, but we also spend some time going up. Okay, that's the opposite of free falling. So, whatever. I just don't think that it's useful to try to make free fall arguments, but whatever. Trying to free fall and are playing a tug of gravity war with each other. Well, the whole point is it's an irrational tug of war. The heavy object is here, down here. He swings down. What stops him and what forces him to go back up? He's heavier. Fuck's sake. So they're clearly in a tug of war with the lever itself. The center of the lever's gravity is the thing moving in the opposite direction to the weight. So when the weight goes down, the center of mass of the lever is moving up, which means this side of the lever is now heavier. You're adding mass to the other side of the lever. The static masses aren't helping you. It's the center of gravity of the lever. That change is the change that's making the change. Gravitational potential is the only way to describe why the weights find the lowest possible state of energy. So this is all their baby talk, this lowest state of energy baby talk. Entropy works both ways. You know what? The universe inevitably creates non-entropy, that is complexity. It inevitably does it. We can watch it do it all the time. There's no, it wants to not do something, or it won't do this, or it won't do, there's nothing. There's no rule against it. There's no law of things like to slide downhill. Well, apparently they love going uphill likewise, because they do it all the time. So it's just, we're just talking about things clumping. And it's kind of silly to say the universe likes to declump. Well, of course, but it's after it liked clumping in the first place, right? It has to clump before it can declump. So obviously it likes clumping just as much as it likes declumping, where the scale is balanced. Whatever. I concede that to do that they are subject to the acceleration of gravity. But if 9.8 meters say you put per second squared, why? Newton didn't say per second squared. It's per 1 second, by the way. Do you get it? Do you get how wrong this is? You're writing 9.81 meters per second squared. When it's the ratio is actually, it's only 9.8 if you have 1 second. In 1 second. So how can you possibly be thinking it's rational to square the number 1, right? Or, I'm just squaring vague seconds. So if I put the 1 in here, and then what are you going to say? Times second squared, whatever the second squared would be, some other thing that you're squaring. The rate is 9.8 meters. The amount you get is 9.8 meters of acceleration per 1 second. That's the fact, and whatever this crap is only just that, crap. Was the only consideration acting upon them, as you say. It is then I could unbalance the scale a small amount, and due to minuscule differences in the field, neither should move, and the scale should stay in the position. Identical weights at equal and opposite distances from the fulcrum would experience the exact same 9.8. But again, I'm arguing that, frankly, minusculely, on the minuscule level, they're not experiencing the same gravitational potential because they're different. They're in different amounts of stream. They're closer. One of them's closer to the light bulb than the other one. This clearly doesn't happen unless these scales are very poor design and the friction at the fulcrum is too great to overcome the minuscule differences in the field of these distances. Well, that's one of my accusations, frankly, is that if you can take a balance and make it stay in an unbalanced position, that some of that might be the very fact that there's not enough energy to overcome the friction of the fulcrum. So gravitational potential energy is the only rational explanation, well, says you, and one has to admit that in essence both the weights are in free fall. Well, again, if they are both in free fall, the one down has more weight and therefore should win. Okay, if one weight is removed and the other is going to free fall till it hits dirt. You're doing it, you're just doing it backwards, right? You're saying it's height from the center of the earth, and you're using that to calculate the wrong gravitational constant. The thing that's lower has more gravity. Please don't subvert my words. Well, I'm not subverting them. I'm frankly not very interested in them. I'll say that. This subject is, to me, way too nuanced and convoluted to give a shit about, and it has nothing to do with any of the primary subjects I would like to get to. And introduce cliffhangers to divert from the correct solution. Well, again, I don't see any correct solution here. So until you draw your example of how the thing in the more gravity is now somehow lighter without getting to a center of mass argument for the whole lever itself, I don't think you're getting anywhere. I provide to you comments about the higher mass being higher in the gravitational field should weigh less. Exactly. So what are you talking about? How does the thing that weighs less stop the thing that weighs more from moving? I think you were saying that in response to someone else's badly contrived lever experiment. I'm not sure because I don't watch any of those other people. Well, frankly, the conversation requires you to, do some backup work. No wonder these people accuse you of being a liar and dishonest. Yeah, fuck you. I've experienced it firsthand where you dodged the correctness of my argument. So frankly, if somebody wishes to interpret his argument and draw it, okay, I might be interested. But I don't know what the fuck he's saying. The objects aren't free falling, so that's silly. They're in some amount of friction. That is, they're putting tension on a stick. Okay, the tension has to fly through the stick. The lever's communicating the tension. I mean, I just don't see how he explained any of that. And the calculations I tried a childish obfuscation with a cliffhanger sketch. Just to point out that this distance argument, we're still just saying the one hanging down has more mass, essentially. It weighs more. Why doesn't it just keep going? How does the light thing stop the heavy thing from moving? That's a simple question. It seems you are engaged in a war with some people on the internet, and both sides are constantly subverting the argument, dodging, sidestepping, and insulting each other. Maybe take some time off. Maybe go fuck yourself. That's reality, fuckhead. Okay? They drew Abraham Lincoln as an ape in the newspapers. Okay? People cheat all the time because people are weasels. Okay? So you have to accept some of that. And you're just a little snowflake and you can't take it. Okay? Then fuck off. Yeah, this is a heated, nasty argument, but you can make arguments. And the fact is you're making all of your arguments in droney text that don't have any illustrations, no figures are included. It's the most boring, shitty paper readable, right? Imagine a physics paper that has no drawings, no figures, no illustrations, nothing. Just text. And then you're complaining because, well, first off, I'm not even interested in this fucking subject. Okay, it has nothing to do with what I'm arguing. It's completely off this subject, and it's insanely technical. In the sense that, yeah, it's all about all this complexity that has to do with this fucking fulcrum and, technically whether the center of mass is a little tiny bit above the fulcrum or a little bit below the fulcrum. I mean, fuck you. I'm not interested, fucker. Can I make it any clearer than that? But I don't think, okay, my impression is your theory is incomplete. That's my impression. Because it really isn't explaining why the heavy thing goes up. Fuck. He didn't do all this, right? This is another comment that's forever long. Fuck. Alright, let's see where this one starts. Who the hell left this one? He didn't sign it. Alexander. Zaptia guy. Alright. This is a response to your video called Springs Make More Momentum? Yes. Because obviously it doesn't make any sense. So he says, in short, no. But of course they do. And he's going to start saying something like, I somehow, I can't make it clearer. I don't believe in negative momentum. I can't say it any clearer than that. I don't believe there's such a thing as unenergy. Okay, when an explosion explodes and stuff goes in all opposite directions, it doesn't mean no energy happened. So we're back to this stupid fucking bullshit where, you know, they say if I crash into something and I can create an elastic circumstance, so this mass is heavier, let's just make it bigger for the sake of argument. I crash into something bigger than this object, okay, in a way that's perfectly elastic, that is with a spring, okay, because if I don't make it perfectly elastic, super elastic, this phenomenon doesn't happen. But anyway, so I can start off with 100 momentum going this way, I hit this object, and somehow I make it go off with 133 if it's twice as heavy. If it's 3 times as heavy, then it's going to be an even bigger number. If it's 10 times as heavy, then it's going to be 200. Okay, so that's the max. 200 is the max. So I start with 100, and I can get a total of 200 as a maximum going this way. So if I make it so it doesn't move at all, it has 200. That's what they're saying. That's explicitly, accurately describing what they are saying. Okay, and then they're saying that, well, going back this way undoes this. So this goes back with 33, so that undoes this. This goes back with 100, then this only went forward with 100, right? So they're saying that there's 100 going both ways. But I only went in with 100 going one way. How can I get 100 both ways? I mean, I actually got 200 this way, but somehow this is undoing one of those 100s. So now I only have 100 going this way. Sorry. No sale. I mean, I'm obviously saying that there's only so much motion, and you have to count all of it. All the vectors count as energy. If I collect both sides of the, again, I can just go to the pop gun. Okay, I have a pop gun. I can, and it has 2 corks in it. If only one cork goes, then the other cork's going to go with twice the speed. But if both corks pop, then there's going to be half the speed. I can't have any other circumstance. Nothing else is going to happen. Either one cork goes out with 100, or 2 corks go out with 50. Okay. I was confused as well while guided by the sequence of events you list. So upon recreating the events and calculating the momentum and velocity. So calculating with, in my opinion, completely irrational logic that there's something called a negative momentum, unmomentum, that you can apply unmomentum and make momentum go away. I can shoot a bullet this way and you don't get killed by the bullet going that way because I shot one that way, and now therefore that one doesn't have any impact in the universe. I'm saying that's bullshit. There is no momentum generated. So, fuck you. It's just too stupid. Let's say the container spaceship is the same mass as 2 balls that are bang against the sides. Yeah, so I already said it works internally. But I just pointed out that I could make a spaceship that's sticky on one side and bouncy on the other side. And all of a sudden now it don't work at all. Alright, the balls will travel are equal but opposing velocities. Yes, the sequence of events is as follows. So we have an explosion. We make 2 balls move with the explosion. So I have 100 going this way and 100 going this way, and they're both going to hit a wall. And he says they're both going to create now twice the energy in the universe. So from the explosion, I'm going to double my energy because the balls are going to bounce. And bouncing means double your energy. And I'm saying, no, it doesn't. Alright, all the masses are independent. Mass of the left ball reaches and sticks to the wall. Yes, well, there you go. So you have 100 going that way. Momentums. Alright. This makes the container a 2-mass object. I wouldn't bother counting the weight of the container. Let's just go for the full 2. But you're not going to gain 2. Sticks to the wall. This makes the container a 2-mass object. So I don't know what that means. No, sorry. The container, because of the inelastic collisions, moves less at a reduced speed because the ball had to accelerate the container. It's stuck, and we're just talking about its total momentum. So its total momentum is divided into the container. It doesn't matter the size of the object, the mass. We're talking about its momentum. We're talking about its mass and its velocity. So clearly, if it sticks, all those experiments are completely consistent. I agree. Professor Lewin agrees. If it sticks, you just divide the velocity into the mass, and you get the new momentum number, which is the same. I mean, it's just mv. You're just saying what's the total mass, what's its velocity, and that momentum number will be exactly the same as what you started with. Momentum will be conserved. All right, this means that for the right ball, the container is approaching. Well, these speeds are so small that, again, why are you doing these relativity arguments again? We're talking about stuff that happens in milliseconds, and you're saying that somehow something moving 4 miles an hour is going to be affected. That is silly. There is an instant in the right wall where the ball stops. Its velocity is 0. The momentum cancels out because the two mass container and the right ball are moving in opposite directions. So this just isn't going to work. I mean, you really think you can do this stuff and people can really follow along and have to draw it themselves? The spring unwinds and the two mass container is thrown right and the ball is thrown left. This throwing thing is the part of the whole argument. It won't bounce if it's thrown. So this is the argument, right? We're saying I'm going to hit something that doesn't move. If the thing I hit moves, then the ball doesn't bounce. That's the whole argument, right? If this yields, then this doesn't bounce. This can't be said to yield, okay, and bounce. I can't give this to momentum and expect a bounce. That don't happen. It can't do both things. It can't absorb the energy and reflect the energy. I mean, so there's something to get out of this, but I mean, obviously, I did these calculations on paper, really. Yeah, there's no calculations to do. You just do the drawings, okay? That's all you have to do is draw it, all right? And you can see it don't make no sense. All right. Just draw this. Look, I drew it in the beginning of this video, so it's already in here. I said you have a sticky side, you have a bouncy side. The implications are that that object, if I put it out in space, it will start moving and going faster and faster and faster until it reaches, the speed of light. All right. And is really nasty and complicated. Using the simple math used in this video, the math in the first 3 minutes. Well, again, this will be horseshit. This will be something like the rocket equation or some other kind of bullshit where you're just making up a bunch of fake variables, but whatever. I mean, you really think. I mean, these are the experiments they've done, right? I have an explosion. I have a very good vessel where the explosion doesn't go anywhere else. It just goes to the objects inside the tube. And I put 2 1-ounce things in the tube, and I have the explosion go off. And they leave with total momentum. This is going a velocity, this is going a velocity. That would be the total. 2 corks fly out. I just put heavier things in. Now they're 10 pounds. The explosion takes place. Boom. And now I have 10 times or 100 times the momentum. That these things somehow gain more momentum from the same explosion, so the total momentum goes up. You think that can really happen. All right, let's see. All right, so this is another comment. Looks like from the same guy. All right. At 1 through the you make the same mischaracterization I accuse you of and you deny. Yeah, whatever. Who cares? I'm just sick of you, frankly. You're not on the subject, and some of the stuff you say is just stupid. Frankly. It moved, but it didn't move. It yielded to the explosion, but it didn't. The two-mass object is not moving initially. So here he's, whatever. Upon the collision, it only gets part of the velocity. It gets more than half. So that the object weighs twice as much, and now it's going to get more than half the original velocity of the one mass, which means it's getting more momentum. It means it is more powerful than what went in. What went in had a certain amount of power as momentum. What is coming out going in the same direction now has more power, more energy, more capacity to move atoms in the universe. You somehow, with your magic box, made the bullet faster because you said, I shot a bullet that way. The bullet went in with a certain momentum. You have increased its momentum, okay? Yes, you decreased its velocity, but you increased its mass, which is momentum. So it has, in fact, increased its momentum. That's a fact, fuckhead. That's what their experiment says. It's a magic bullet enhancer, okay? Because the bigger and bigger and bigger I make the bullet, the more and more powerful I make its impact. Because its momentum is its impact, its weight. It now has more crushing power. Okay, the two-mass object is not moving initially. Upon the collision, it only gets part of the velocity. It's, frankly, again, this is crazy. Because it's, in frank truth, it's getting 2/3 where, it's going to have more momentum. All right, from the one mass object going the velocity in question. So yes, it's explicitly true. It's only part of the velocity, but frankly, there is no part of the velocity in this equation because the mass and the velocity have to be considered as wholes. So I'm just saying it's clearly not part of the momentum. It's clearly getting more momentum than the original object started with. Therefore, if an object starts with 100, after the collision it can't go 133. So no one said it had a 100 velocity. The argument is its mass and velocity equals 100. Not that its velocity is 100. So you didn't even understand that? After all these videos, you got that wrong? The argument, I'm not arguing it has 100 velocity. I'm arguing its mass times its velocity equals 100. And then when it comes out of the experiment, its mass times its velocity equals 133. Fuck you. If an object starts with 100, after the collision, the object can't go 133. It cannot. So again, no one was talking about 100 as ever being its velocity. So again, I don't even know how you could make that stupid fucking mistake. It was always the momentum. Its momentum was 100. And then when the two mass leaves, it has a momentum of 133. Clearly, an increase in the momentum. Nobody says it does. The equations do not say this. So I can't believe this horse shit. See, this is why it's just such a waste of time, because they don't understand the subject matter. They can't interpret it correctly, and then they accuse you of cheating them. Fuck, when I have to do this all the time, correct all these fucking mistakes you're making. The equation says that 66 of the initial momentum, so that's bullshit. It's 66 of the original velocity. Not 66 of the initial momentum. You can't get any of this right. Now he's perverting it and calling the momentum velocity. Oh, man, are you so full of shit. The equation says that the 66th of the original velocity, not momentum, okay? You got 66% of the original velocity, not the original momentum. that means that 66 is not 166, not 133. So 66 will go to the 2 mass object. 66 velocity. 66% of the velocity. Ay, god damn, dumb fuck. So 66 will go to the 2 mass object and 33 of the momentum. So again, that's the exact, you're just fucking the whole thing up. And 33 of that momentum goes to the mass object because it bounces back, so it will go 33. It's not going 33 velocity. It has 33 total momentum. So again, you're just so goddamn... Alright, so there's no point in reading the rest of this, right? Because he's just wrong. I was given several links where you use the wrong numbers characterizing the argument you oppose, just as you have done here. Liar. Okay, there's 10 million videos of this, as we found out. Okay, there's not that many. On the internet. And every single one of them is filled in shit-a-vision, or they do crappy frame rates, or they do some other kind of bullshit. They don't tell you the masses, some other kind of shit. Okay, they're all flawed. And obviously, this is something, Brozo made an air track. He couldn't get it to work very good. And frankly, he couldn't get it to work at all without the spring. And that's why I titled the video the way I did. Because apparently you people are thinking that springs multiply energy somehow. Okay, in the very comment where you clarify it. So anyway, you're just wrong. The math derived from the kinetic energy predicts a bounce. That is why the object gets each a portion of the initial momentum. So clearly you don't understand this subject at all. Clearly the twice as massive object isn't getting a portion of the momentum. It's getting more momentum than went into the experiment. Under the conditions of it being an elastic collision, the video from the teacher shows a bounce, which is a powerful prediction. So duh, they all predict a bounce. Everybody predicts that. So nothing new there. That's a Newton cradle experiment, for fuck's sake. I do not know reasoning using momentum only that will predict circumstances for objects' bounce and ending velocity. So again, they won't predict these velocities. That's the whole point. Momentum says you're breaking conservation of momentum because momentum isn't subtractable. There's no such thing as minus momentum. Again, the cork experiment. I put pressure into a gun. The 2 corks fly out. They will go half the velocity that they would have gone if only 1 cork pops out. If 1 cork pops out, I get twice the velocity than if 2 corks pop out. The corks can't undo each other. Fuck. Alright, so, alright. So then the Tyler Johnson. I've been to a federal court, you fuck. Yeah, because, for real crimes, right? Accusations that you committed real violations of statutory law. So how does that change anything, Tyler? Look, Tyler, you're not going to be sued because you're a schizophrenic. Okay? I'm not going to bother with you. You obviously have some problems. And the annoying part is that I actually believe you're intelligent enough to know that. That you are smart enough to know you got some bugs in your brain. And that unlike other people, where they have an impulse, like they see a chick and they say, boy, I'd like to squeeze her boobs. They have some kind of impulse. They know, I got to count to like 3 or 7, and not act on that and think about it. And think about, yeah, wait a minute, I don't want to I don't want to be rude, or I don't want to go to jail. And, they figure out, don't do it. And so if you know you're a schizophrenic and you have these reliability arguments, problems, then you can't just count to 3 and you can't count to 10. You probably have to count to 168,000 before you act on your impulses because your brain is fucked. It's not completely fucked. It's just fucked in the sense that there's this disorder between your impulses and what you do. And that you have to, you have to be able to not get into a cycle of allowing your impulses to control you. Now, I'm just saying you're smart enough to know that, but you don't do it. And that's a colossal failure on your part. That's a character defect, that you won't take responsibility. You're smart enough to take responsibility for your disorder. It's kind of like that mathematician guy, right? the guy, the famous mathematician who was a schizoid. And, he knew, he's crazy. And so he compensated for it and got a Nobel Prize out of the deal. Because he said, yeah, okay, I know I'm nuts. I can't get lost in my delusions. I can't get lost in these wacky conspiracy theories and other bullshit. I got to try to keep grounded and just say, coffee. My cup of coffee is reliable. The crap in my environment's reliable. I'll depend on those things, and I won't depend on the little voices in my head and thinking the dog is talking to me. Yeah, I won't get lost in that crap. Anyway, there's no point. He's not gonna do his own. I'm just saying. There's just, like I said, I empathize that you have a disorder, a little lack of perfect functionality, but I really don't appreciate that you're taking over responsibility for it. So anyway, okay, enough of a statement. Moving on and such. Yeah, I think that's everybody. Oh, I didn't have the comments back up. So I didn't even have to acknowledge the existence of that crap. He's the guy who said something about killing, black people or some other kind of wacky, crappy. I mean, he gets these things and he says this shit. And he really does know better, but he just doesn't count long enough before he hits that enter button. All right, anyway. So anyway, this is all the crap you missed. This is just crap, so you didn't really miss anything. No pictures. All right, no videos, no nothing. Just crappy words by crappy people. All right, so till the next time and such and so forth. I really think that's enough. So I'm going to hit the, an hour and 20 minutes. Yeah, it's more than enough.